We're in Algebra 1. Today's date is Tuesday, February 12th, so write it down, February 12th. Make sure your name and notes are, or your name and date are on the paper. I can actually see now. All right, so vocab. When I say a solution, what do I really mean? Quiet raise hand with a card. A solution to a system of equations. Yeah, Fernando. Point. Yeah, so a point. And if I have two lines, it's the point on both of those lines, right? Point on both lines. And when I say point, or when Fernando says point, you're talking about an x-coordinate and a y-coordinate, right? Yeah. At x, comma, y. Exactly. That's our bit of review. All right, Fernando, you can turn in your card. Let's come over here to give xp away. So this video is for Cohen, Eder, and Sergio. You guys are gone today. All right, so we have this giant table to look at different solutions in different forms. So, by the way, we've been doing one solution. Everything that we've been doing thus far in all of Algebra 1 is one solution. So we've been in this column right here. And then I'm going to introduce column 2 and 3, zero solutions and infinite solutions. Well, so if you don't know how to pronounce this symbol, it's infinity. And I'm going to be, since it's an adjective, it's infinite. Infinite. There are an infinite number of solutions. That's the symbol for it. It's like a 8 that fell down onto its side. Infinite solutions. We deal with infinity a lot in calculus, so maybe we'll get there one day. All right, so a graph of one solution. So we're always assuming that we have two lines. Is it possible for those two lines to hit once? We all nod our heads. Yes, it is. Go ahead and draw any two lines that cross once. It doesn't matter exactly, or if they look exactly like my graph or not. I'm just going to draw a line like that and a line like that. And say, oh yes, so make sure that it still has arrows that go off forever and ever towards infinity. Yes, they cross once. It happens right there. I'm going to make a giant dot. Yeah, that has one solution. Those lines cross one time. That corresponds to one solution. One cross, one solution. We all nod our heads. Okay, that crosses one time, one solution. Matches Fernando's definition. How could we have zero solutions? Quiet raised hand. How could we have zero solutions on a graph? Julian. If they don't cross. So what would they look like? Can you do it with your hands? Ah, so the lines are parallel. They never cross. Okay, so go ahead and make parallel lines that never cross, just like Julian's hands. I'm going to do mine like that. You don't have to make yours exactly like mine, but you have to have two parallel lines. Yeah, those lines will never cross. They have the same distance in between them. Thank you, Julian. You can turn your card. Thank you. All right. Ooh, okay. So now the tricky question. How can I have an infinite number of solutions? How is that possible? Given only two lines, how can I have an infinite number of solutions? Anyone have an idea? Infinite. So that's one. How does it cross more than once? Oh, that's tricky, right? Anyone have an idea? All right, I'll give it to you. Oh, you think you got it?
Yeah.
All right, go for it, Andres.
When both lines are loose, like they overlap.
Yeah, exactly. They overlap each other. Make two lines, one on top of the other. So here's my first line. My first line looks like this. So far, so good. Here's my next line. I'll do it in a different color. Oop. Actually, there we go. Here's my next line. I'll do it in a different color. Come on now. Is it going to let me make a line? Make a line. Okay, I'm going to do it like this, and I'm going to put it on top of it because technology is not my friend today. I'll put it right on top. Boom. There's an infinite solutions. And to make it, yes, turn your card. Good job. That was a hard question, too. There's my first line in red. My other line right behind it was in blue. One line on top of each other. And if it's not clear in your notes, you can say on top of each other. On top of each other. And we can say here that this was parallel. All right, let me make sure to record Andres. There's your 50 XP. All right, so that's the graphical interpretation. So we have two homework assignments tonight. One of them is graphing equations, which is all review. I know it's still hard for us because we haven't had very much practice, but it's all review. and we'll practice that today. Graph them, and if it's this type of graph, it's one solution. If they're parallel, it's 0 solutions, and if it's the same line, it's infinite solutions. All right, this is going to apply to tomorrow's lesson, but I thought I might as well teach it and just review it tomorrow. Whenever you're trying to solve, by the way, what are the 3 ways that we have to solve a system of linear equations? You can solve a system of linear equations by graphing. That's one of them. What's another one? Quiet raised hand. I'll even pull up our unit guide. It's in our unit guide somewhere. Graphing, that was lesson 1. What is another one? Zoom in so you can see it from all far back. Quiet raised hand. What's another one? We had graphing. What was our next method? I know Fernando and Andres have an answer. Josie, go for it. Elimination. There it is. Yeah, that was lesson 2, elimination. And what was our last one that we just learned? Gunnar. Substitution. Yeah, Josie, Gunnar, please turn your cards. Gunnar's right there, and Josie is right there. All right. So if I'm solving using those 3 methods, so I'm either graphing like we did up here, or I'm doing elimination or substitution, this is what's going to happen with the algebra. In terms of the algebra, we've seen this before. You get an x equals to a number. So x equals, I don't know, I'm choosing a random number, 7. And you get y equals to a random number, I don't know, -1. You'll get something like that when you use elimination or substitution or graphing. You'll get some answer. Whenever I do the algebra with elimination and substitution, what I'll get for 0 solutions, I'll get something that is clearly not possible, like 1 equals 7. That is not possible. Therefore, there are no solutions. By using elimination substitution, you're saying, assuming that these lines intersect, what happens? 1 equals 7 means, hey, they don't intersect. They never have a solution. And when I have infinite solutions, I'll get something like this. 0 equals 0. How often does 0 equal 0? The answer is always. That happens everywhere. 0 equals 0, 1 equals 1, something like that. You can have 0 equals 1. Something that doesn't happen is 0 solutions. Something that always happens is infinite solutions. Not super important for today's lesson, but it is going to be reviewed in tomorrow's lesson. Here is the really key part of today's lesson. That's why I put a giant star here. In terms of these 2 lines, what do you notice about their 2 slopes? Are they the same or are they different? That's the main question. Quiet raised hand. Are they the same or are they different for these 2 slopes of those lines? It's not a trick question. Quiet raised hand. Are they the same or are they different? Go for it, Jenny. Yep, just write different. Thanks, Jennifer. Jenny. And what about their y-intercepts? And this one's, I'm going to do it for us. We don't care. We don't care. As long as the slope is different, we know that they're going to cross once. All right. What do you notice about the slope for parallel lines? Quiet raised hand. The slope of those parallel lines. I see one hand. I'm going to have to call on people that I haven't called on before. So I'm looking at Jessica, Monse, Jose. Yeah, go for it, Jessica. They're the same, yeah. They're the same slope. This has a slope of maybe a half. That has a slope also of a half. But here's the key part. What are the y-intercepts? This y-intercept is right here. This y-intercept is right here. So are the y-intercepts the same or are they different for the y-intercepts right here? Quiet raised hand. You want to go for it, Jose? Go for it. Same? Yeah, okay. Different. You're correct. All right. So write it down for our notes. And did I give Jessica her... Oh, that's the wrong button. I did not. All right. So Jessica, there you are. And Jose, there's your 50. All right. And then using the words same or different, what can we say about the slope for infinite solutions? What are the slope of those 2 lines? Are they the same or are they different? So I think it has to be Monse, right? You're the last one. So you got a 50-50 shot. Are the slopes of these lines the same or are they different? There, yeah, they're the same. Write it down in our notes. Thank you, Monse. You can turn in your card. All right, is there anyone else that still has their card? All right, everyone else can participate multiple times. So when these two lines are on top of each other, their y-intercepts are the same or different? Quiet raised hand. Same or different? Julian? Same, yep. Thank you, Julian. I'm just getting more and more XP. All right. So really take some time to digest what's happening here. This is the really key part that I care about. That's the new information. Obviously, we knew that the slope was different. That's important as well. But in terms of the difference between zero solutions and infinite solutions, both of them have the same slope. But one of them has a different y-intercept. One of them has the same y-intercept. We're really digesting that? Okay. That's going to help us solve these problems. So let's do an example. Example 1. We're going to graph the system, and then we're going to... Oh, we had a typo right here. How many solutions are there? 1, 0, infinite. So we need to graph this first. Well, I can graph this one right away. This one is in slope-intercept form. Can someone help me graph slope-intercept form, Fernando?
Place the 1 on the y.
Yep, so we're going to do the y-intercept first. I'm doing the 1. 1 goes on the y-axis. So I have my first point. Thank you, Fernando. What do I do next, Fernando?
You go down 1 and then right 2.
Yep, this says go down 1, negative 1. So down 1 is to this point, and then right 2. Down 1, right 2. I'm using the slope. So down 1, right 2, and there's my next point. Thank you, Fernando. You get some XP. Make those 2 points. Make sure you remember how to graph slope-intercept form. I first graph the y-intercept, and then I graph the next point using the slope. And if you need some reminder, this bottom number tells you how much to go to the right. This number right here tells you how much to go up versus down. All right, and I can graph that same point again. So from here I go 2 right, 1 down, 1, 2, 1 down. I can have a bunch of points. I can do 2 left, 1 up, 2 left, 1 up, and I can have a ton of points. Go ahead and graph a line. Oh, shoot, we forgot to grab rulers, didn't we? All right, let's pause and grab rulers. Now that we've graphed our first line, that was our, I'm going to say that this was going to be the blue line. How do we graph this line? Technically, it's in standard form, but I think from now on, let's just practice converting everything to slope-intercept form, because it'll make these facts down here much more evident, because we'll be able to immediately see the y-intercept and the slope, because it's in slope-intercept form. So how do I convert this thing so that y is by itself, this 2 and this x are moved to the other side? Whoa, what happened there? Come on now. If I scroll down and scroll back up, usually it reloads. There it goes. How do I change this into slope-intercept form? What do I do? Do I get rid of the 2 first? Do I get rid of the x first? What's my first step? Only one person knows. Uh-oh. 2 people? Jose, what am I going to do? The 2, what am I going to do with the 2? I can divide on both sides, yeah. That is a slightly harder step, but it's still mathematically valid. Let's go ahead and do it. So if I divide every single term by 2, I'm going to say that's going to be divided by 2, that's going to be divided by 2, and that's going to be divided by 2. I'm going to write it down here. Now I have x divided by 2 plus, and these 2's will cancel out. There's no more 2's for the y. I have plus y is equal to 4 divided by 2, which is 2. All right. So Jose's step dividing each term by 2 makes our y isolated, but now we still have this pesky x divided by 2. I need to somehow move that to the right-hand side. Let me give Jose his XP before I move on to the next person. How am I going to move x divided by 2 to the right-hand side? Fernando's ready to go, but I need to make sure that everyone else knows what we're doing also. How do I move this x divided by 2 to the right-hand side? Right now it's being added to y. I need to undo this addition. I hear Josie whispering it. Subtract it, yeah, exactly. So I'm going to subtract x minus 2. So I'm going to say minus x divided by 2 minus x divided by 2 on both sides. That will get rid of this x divided by 2 on the left, and on the right I'll have x minus 2. So my new equation here, and I will do it in red. My new equation, I have y left over on the left. I have y on the left, and on the right-hand side I have 2. That was still left over. And I now have this negative x over 2, or minus x divided by 2. I know we had to kind of cram it in there. All right, so our slope is right here. And in fact, if you don't like writing it this way, you can write it a slightly different way. This is the same number as negative 1/2 x. Negative 1/2 x and negative x over 2, those are the same number. You can change these back and forth. So this is slope-intercept form. I know that's slightly backwards because we have the intercept first and then the slope. But who, not Fernando because he did it last time, who can help us graph this, now this in slope-intercept form? Remember the steps. Graph the y-intercept, then use the slope to find the next point. Graph the y-intercept. Quiet raised hand. What's the y-intercept? Jose's been answering lots of questions also. I want to see if I can get someone new. Not our power duo of Jose and Fernando. Someone new. Please, I want to make sure that people know what we're doing. Yeah, Andres.
You graph 2 on the y-axis.
Exactly. Graph 2 on the y-axis. And there it is.
You go down 1.
Down 1.
And then right 2.
And then right 2. Exactly.
Or left 2.
Oh.
Since it's negative.
So down 1 came from the negative. So we already used up the negative by saying go down. So you're correct. We say down 1, left 2. Down 1, left 2. And there it is. Wait, shouldn't it be right 2 though?
Yeah, right 2.
Yeah, down 1, right 2. So it should be like that. Down 1, right 2. And I can do the same thing again. I can use Andres' rule of saying down 1, right 2. And I can go again. Down 1, right 2. And I can go backwards too. I can go left 2, up 1. Left 2, up 1. And then go ahead and make a line that goes through all those points. All right, and then our final question, our new step for today. How many solutions are there? Looking at that graph, which one does it match up here? Gunnar, go for it.
Infinite.
Infinite solutions? Careful, Gunnar. So is it graph here or graph here?
Solutions.
There it is, yeah, 0 solutions. Tomorrow we're only going to be doing this without graphing, just by looking at the slope. And notice what happened with our slope here. We had a slope, you don't have to write this down, but look, we had a slope of negative 1/2, and we had a slope of negative 1/2. The same slope, but our y-intercepts, for the first one was 1, our y-intercept for the other one was 2. So they had different y-intercepts, which matches with the information that we have in our table. All right, we're on to the back. Again, graphing. So, obviously we can graph this one right now. It's already in slope-intercept form. We don't have to convert it. So who can help us graph this one? Slope-intercept form. Same 3 people. Jessica's hand is on her head, not up. Same 3 people. All right, we'll give it to Fernando. He's been patiently waiting.
Graph negative 1.
Yep, graphing our y-intercept first. So graph negative 1 on the y-axis.
And then go down 3 and right 1.
Down 3, right 1. Because this is really the slope of negative 3 over 1. So down 3, right 1. And then we can go the reverse of that. He said down 3, right 1. That means I can go up 3, left 1. Up 3, left 1. So I have a bunch of points. Go ahead and make a line that goes through those points. All right, I need to get some water. Go ahead and try to convert this first equation into slope-intercept form. All right, so we're back. I saw many people take a good first step of dividing every single term here by 2. Can you nod your heads if that was your first step? All right, that's a good one because we need to get this pesky 2 out of the way. So divide every single term by 2. So divide by 2, divide by 2, divide by 2, and that left us with an x minus y is equal to negative 3. All right, now we have to get rid of this x and we have to get rid of this negative. So I'm going to get rid of the x first. What I'm going to do is I'm going to subtract x from both sides, minus x minus x. Those x's will cancel out. I'm left with a negative y is equal to, and I have a negative 3 minus x. Negative 3 minus x. And this is the time where you can ask questions. I'm almost done. I still haven't solved it for y. I still have a negative y. Quiet raise hand. What am I going to do to get rid of a negative in front of the y? Only one person knows. I know that most groups know how to do this. can't add y. I'm going to have to multiply or divide by something. Just go for it, Jessica.
Multiply each term by -1.
There it is, yeah. Multiply each term by -1. So -1 is going to get multiplied here, -1 times here, -1 times here. And that will leave me with my new equation, which is going to be y. There's a negative times a negative is a positive. I have a -1 times a 3, which is a positive 3. I have a -1 times a negative x, which is just a positive x. So 3 plus x. And there's our equation. So now I need to graph that one. I'm going to pause here to make sure that everyone can follow those steps. All right, someone help me graph. Help me graph. Go for it, Jose. Graph the 3. So 1, 2, 3. And then, Jose, what do I do next?
Down one and then right one.
Yeah, careful, so it's a positive
Oh,
slope.
yeah. So up one and then right.
Yep, so it's 1 over 1 in front of this. So I go up 1, right 1. Up 1, right 1, make a point. Up 1, right 1, make a point. And then the opposite of up 1, right 1 is down 1, left 1. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Make a bunch of points, as many as you need to be accurate, and then go ahead and make a line through those points. All right, we can see that it crosses once. Right there, I'll circle it. Therefore, how many solutions does our system have? Monse, go for it. Yep. 1 solution. All right, graphing is pretty hard. It is a good thing to know how to do, though, especially for the higher levels. So, Jose, I forgot your XP. Monse, there's your XP. Am I forgetting anyone? Fernando, I figured. Sorry about that. Anyone else? Are you sure? All right. Oh, Jessica. I did remember. Or I did not remember Jessica. Okay. All right, let's go to finding number of solutions without looking at the graph. So now we're purely looking off of this information right here. You're purely looking at the bottom 2 rows of your table. All right. So let's first look at the slope. These 2 equations, do they have the same slope or different slope? Quiet raised hand. Same slope or different slope? Monse. Same slope. It's the same number in front of this x. This 3/2 and this 3/2 are the same. So go ahead in your notes, just say same slope. So if we're in same slope, that means we're in either this column or this column. So we're either in 0 solutions or infinite solutions. Well, now to determine the difference between 0 solutions and infinite solutions, I need to compare the y-intercepts. So let's undo that. The y-intercepts. And now you've seen the y-intercepts. What's the answer? Is it 0 solutions or is it infinite solutions? See, Andres has a hand. Other people are looking at it. Look at your table. Josie, go for it. Infinite, careful. 0. Why is it 0 solutions? You could call on someone else if you don't know. She calling you Andres, yeah?
0 solution because they have a different y-intercept.
Yep. Write it down. Different y-intercept. So Josie was right in thinking that it is in one of these 2 columns because it's either 0 solutions or infinite solutions since it had the same slope, but the y-intercepts were different. The y-intercepts were different, which meant we were with 0 solutions. And again, the y-intercept is just this number at the very end here. So our answer here is 0 solutions. And since that's kind of hard to see at the very end of the day, we'll make sure to box that. Why is this? There we go. All right, another example. All right, how many solutions does this one have? First check the slope. Then check the y-intercepts if you need to. Check the slope. Andres just answered. Fernando's been answering a lot already. See if I can call on someone new. Build someone's confidence. Let someone grow. Who's got this one? Check those slopes. Check the number in front of the x, the coefficient. That will give away the answer. Julian, yeah, go for it. No solutions? Why'd you say no solutions? A one solution? Oh, why'd you say one solution? Yeah, slope is different. These numbers right here were different. So right here, different slope. Different slope. And because they have a different slope, we know in the table the only one that has a different slope is this column. This column says one solution. We don't even care about the y-intercept. It's different slope. So it's one solution. Thank you, Julian. I think I forgot to give Andres and Josie their XP. Josie gets XP. Andres gets XP. And Julian gets XP. And our final example. We're almost done. Uh-oh, it's not in slope-intercept form. So we need to convert this bottom equation into slope-intercept form. What are we going to do to every single term here to get this y by itself? Go for it, Jessica. Yep, divide every term by 3, divide by 3, divide by 3, divide by 3. Our new equation here, I'm going to write it off to the right-hand side, is going to be what, Fernando?
Y equals 4x.
4x plus 1. Oh, that kind of gave it away. Okay, how many solutions do we have then, Gunnar? Infinite. So practice drawing your infinite symbol. Infinite solutions. Or you can write out the word infinite if you want. But there it is, infinite solutions. All right, let's see here. Gunnar got some XP. Jessica got some XP. And Fernando got some XP. All right, and that is it. Any questions before we begin our homework? All right, go ahead and write your summaries.